Guys, so this first chapter that we're going to be doing is called Chapter P, and it stands for the prerequisite chapter. Basically what that means is kind of the things that we should know, before you even jump into Algebra 2. These should be things that you learn in Algebra 1, but I will say a couple things about it. Number one, it goes pretty quickly. In Algebra 1, you learn all these exponent rules lesson by lesson. Like you first learn when to add exponents, and then you learn when to multiply them a different day, and things like that. Well, this first lesson, we're talking about exponent rules, but we're going to jump in and talk about all of them in one lesson. So when to add them, multiply them, negative exponents, zero, things like that. A lot of times what I do, instead of just teaching rules, here's what you need to do and when, I like to show you the idea behind the rule and why they are what they are. And I think that helps in terms of if you forget what the rules are, but you have another way to get to the answer. I'm big on that. I'm big on problem solving, finding a way to get to the answer. It's not so much you have to do it the way I say it, but you need to find a way to get to the answer. That's a big thing in this class. All I need to see is your process. If there's steps along the way, then I need to see some work and kind of what you were thinking. But I am big on just finding a way to get to the answer. So I want to start with some of the basics and what you should have learned, back in Algebra 1. And the very first exponent rule you guys learned was if you're multiplying things with the same base. X to the third times x to the fourth. Hopefully we learned when that happens, you keep the base and then you add the exponents together, right? Now, the idea behind that, because a lot of students will look at that, especially being removed from math for a while, they'll look at that and say, well, what about x to the 12th? When do you multiply them? And I want to explain why we add our exponents in this case. Think about what x cubed really means. X cubed is x times x times x. And then you're multiplying that by x to the fourth, which is x times x times x times x. So you're multiplying x cubed times x to the fourth, and now think about what you have here. If you're multiplying x by itself 7 times, that's why we're adding them and getting x to the 7th. So that is why we add our exponents. The next basic rule is if you're taking a power to a power. And then we'll jump into some of the examples here. If you have x to the third to the fourth power, this is your case where you're going to actually multiply your exponents together and get x to the 12th. Again, the reason why, think about what x cubed actually means. Being raised to the fourth power. This means x cubed times itself 4 times. If you would expand it out. Now, I'm not saying you have to show this in terms of work. These are basic problems where if you just jump straight to the answer, that's fine. But this is what it actually means, and then you can kind of revert back to the previous rule, and you're just adding 3 4 times. So that's why that is what it is, okay? So if we jump here and we're multiplying these two things together, we're going to treat it like kind of 3 separate things. The first thing we're going to do is multiply our coefficients together, and we get negative 12. Then when we multiply the x's together, well, think about what that means. If there's no exponent, there's really a 1 there. You're doing x to the first times x to the first, so you would get x to the second because you would add them together. And then same thing on the y's. Y to the fourth times y to the negative third. Well, we're just going to add those exponents, and we get y to the first. And there's our answer. A lot of times students might look at that and think, well, shouldn't we distribute all this stuff? Well, if there's no plus or minus signs inside these parentheses, then you're not foiling or distributing or anything like that. You're just multiplying the like things together. On B, well, now when you have all this stuff being raised to the third power, it's kind of like this 3 is being distributed inside to all these exponents inside of here. And think about what we just talked about. Power to a power, you're multiplying those, and that's why we're getting a 12 right there. Well, okay, let's do that. So this 3 has to be distributed to all the exponents inside. That 4 has a 1 exponent. The a has a 1 exponent. And so when we distribute the 3, a big mistake students make is when they take the 3 to the 4, they'll put 12. But you're not multiplying 3 and 4 together. you're doing 4 to the third power. 4 to the third power is 64. And then you're multiplying 3 and 1 together, and then b to the 6th. So you're multiplying the exponents there. All right, next one. And when we do these notes in class, a lot of times, instead of me just like saying, here's how we do each one, I like to call on people, see what you guys would do, so you guys could see what some common misconceptions are. I think it's good to see people do wrong things, as weird as that sounds. I think that's when a lot of learning happens. A lot of learning is going to happen from you trying a problem, messing up, and then learning what you did wrong. So the next one. Okay, well, let's think back to Algebra 1, and let's think about what anything to the 0 power means. See if you remember. Anything to the 0 power. Like, for instance, if I had 5 to the 0 power, what that is. Some people might say 0. Some people might say 5. But it's 1. Anything being raised to the 0 power is equal to 1. So 5 to the 0 is equal to 1. So that's just an exponent rule we need to know. Now again, if we think about why, I always like to talk about why. I think this is important. And I'm actually going to show you guys 2 different reasons why, 2 different ways why anything to the 0 power is 1. That seems kind of weird, right? Anything to the 0 power, you feel like it should be 0. Well, here's the first thing. I'm going to do a little pattern. Right? Okay, think about what these things mean. So 5 cubed is 125. 5 squared is 25. 5 to the first is 5. And so think about what's happening every time you reduce a power by 1. Every time you reduce an exponent by 1, you're dividing the result by whatever that base is. So like we're dividing by 5, dividing by 5. And so if we continue that pattern one more time, and we divide this by 5, we get 1. So just kind of a little proof there. The other way we can kind of think about that is this. You know, if we had 5 squared divided by 5 squared. Okay, and what do you think about 5 squared divided by 5 squared? Well, if we would actually, divide this out, this would be 25 divided by 25. So we know this is 1, right? We know that's the case. Well, if we're doing our exponent rules, when you're dividing, you subtract your exponents. So we would keep the base, so that'd be 5, subtract the exponents, and we get 0. So we know for sure this is equal to 1. We know for sure this is equal to 5 to the 0. And if you think back to geometry, and you guys learned the transitive property and all that stuff, well, if 2 things are equal to the same thing, they're equal to each other. And that's a big thing of mine in math, is not just knowing what the rules are, but kind of the background behind them and why they're working and why they're doing what they're doing. So going over to this example here, it's important to realize what's being raised to the 0 power. A lot of times students might see this and think, oh, the answer is automatically 1. Well, it's not. We have to do a PEMDAS, basically. So PEMDAS says parentheses, which means simplify everything inside the parentheses. And then it means exponents. And that comes before multiplication. So we're not going to actually multiply these 2 things together. We need to do this part first. That right there is 1. So really, 5x times 1 is what's going on here. And then that's just 5x. When you have a fraction being raised to a power, just like part B up here, that exponent just distributes to all the things inside here. But again, the biggest thing, make sure you don't do 6 times 3. It's not 18, it's 6 to the third power, which is 216. And then that's a to the 9th, because we're multiplying our powers, divided by c to the third. All right, and the last thing is negative exponents. So we've learned when to add the exponents, when to multiply them. we talked about subtracting exponents right here. We talked about 0, and now negative exponents. So 5 to the negative second, pretty common misconception that students might say that's negative 25. But a negative exponent doesn't mean a negative answer. A negative exponent means reciprocal. Negative exponents mean reciprocal. In this chapter, there's going to be a lot of simplification. Not really solving, but you're going to be simplifying a lot. And students struggle with simplifying more than solving, because with simplifying, it's like you don't know when you're done. You don't know what your answer is supposed to look like. But when you're solving stuff, you know your answer should be like x equals 3. You know when you're done. And so with simplifying, if I ask you to simplify, I don't want any exponents of 0 in your final answer. I don't want any negative exponents in your final answer. You got to deal with it somehow. And your final answer should never have like 2 of the same base. It shouldn't have 2 x's in it or 2 y's in it. That's why these exponent rules exist, is to deal with those situations. Okay. Anytime I see negative exponents, I pretty much always create fractions if there aren't fractions already. You notice in B and C, there's fractions there already. But in A, you could turn anything into a fraction by putting a 1 underneath it. And now, anything with a negative exponent needs to move. So what that means is this 5 to the negative second needs to move to the denominator, and the exponent becomes positive. So anytime you're moving things with negative exponents from top to bottom or bottom to top, the exponent becomes positive. If you move everything from the top to the bottom, there's still a 1 as a placeholder right there. Now it's important to understand this 1 did not really flip and go up here. Okay, that's not really what happened. And you'll see what I mean by that on part B. And so to simplify this, it would be 1 over 25. Now, you have these calculators, and if you type 5 to the negative second, it's going to give you some decimal, and I'm not going to let you put any decimals. Like, these would be questions that would be non-calculator to see if you understand the concept versus just pushing the buttons. All right, a couple more. So, B, okay, my advice is this. Find anything that has a negative exponent and move it and make it positive right off the bat. I'm going to show you what not to do on this problem. So what I would not do is say, oh, I'm just going to take this 3x to the negative second and move it up, and then it becomes 3x to the positive second. That's wrong. So don't write that answer. We need to find what has a negative power. This negative 2 has nothing to do with this 3 right here. Like, those don't go together at all. The only thing this negative 2 is affecting is the x. I mean, think about the power on the 3. That 3 actually has a positive exponent. It has a 1. So that 3 is going to stay on bottom, but the x to the negative second is going to go to the top. So it's going to be x to the positive second on top, and then that 3 just stays on bottom. So just because you see a negative exponent doesn't mean you just start flipping everything. You have to find what has the negative exponent and just move that thing. Okay. This one here, you can attack this several different ways. And that's a beauty of math that I find is a lot of problems you could do multiple ways. And I'm not going to tell you how to do a particular problem. If you can find a way to get to the answer, then by all means, get to that answer, okay? But here's one thing. I'm going to show you guys a couple different routes here. Option 1 is inside the parentheses, we can move this y to the negative third up. You know, the 5 and the x have positive powers, so they stay on top, but that y comes up. I personally do not like distributing negative exponents. It's not wrong, but I find a lot of students make mistakes when they distribute negative exponents. Again, it's not incorrect. There's ways you could do it, but I'm not going to show it that way. So what this means is this whole thing is being raised to a negative exponent. So if I want to make that exponent positive, you're allowed to. You're allowed to make the exponent positive on the outside. What you do is take the reciprocal of what's on the inside. That means flip the fraction. And again, this is a fraction. It's over 1. We're going to flip it. and make it 1 over 5x squared y cubed. So anytime you want to make that outside exponent positive, take the reciprocal of what's on the inside. Now, our last step, distribute this 2 to everything inside the parentheses. So 1 squared is still 1. 5 squared, remember it's not 5 times 2, but 5 squared is 25. And then multiply the exponents. X to the 4th, y to the 6th. Your other option, you could flip it right off the bat. You know, I moved the y up at the beginning, but you could do this. You could make that 2 positive right off the start, and then take the reciprocal of what's on the inside. Again, no signs change when you do this except for the outer one, so you can make it be y to the negative 3rd on top, and then 5x squared on bottom. So you made the outside exponent positive and took the reciprocal of the inside. Then you have options from here. You could distribute the 2 inside. You know, you can move the y to the negative 3rd down, and then it becomes identical to this step right here. So you have options to get to that same exact answer. Just a couple different ways to start. All right, last one. We're not going to do scientific notation. You know, we're going to take some things out, and that's one thing that we are going to take out. The last one, 3 to the negative 2nd plus 4 to the negative 1st. I want you to try it. You know, pause it if you want to and try it. I'm a firm believer in if you try the problems yourselves, you're going to find the mistakes ahead of time of what you're going to make. So the common wrong thing to do on this is to put this whole thing over 1 and then flip the entire thing. This is wrong. Don't write this. But a lot of students would do 1 over and then 3 squared plus 4 to the 1st. And then that's 9 plus 4 and say, oh, 1/13. And that's wrong. 1/13 is not the answer. Incorrect. What we're going to find out in this class is plus and minus signs kind of wreak havoc with algebra rules. That becomes a really big deal as we move through this course. But you actually need to flip each one of these separately. Think about what 3 to the negative 2nd means. 3 to the negative 2nd means 1 over 3 to the 2nd. 4 to the negative 1st means 1 over 4. And now we're just adding 2 fractions together. We have 1/9 plus 1/4. And anytime we add or subtract fractions, we have to get common denominators.
Good morning, fair people.
So 4
Hope you're having a great
over
day.
36.
Resource Department meeting has been relocated.
Relocated.
It's no longer on Google Meet.
Not on Google
Meet. In person on junior senior cafeteria at 11. Again, Resource Department meeting meets at the junior senior cafeteria at 11 o'clock. Thank you so much. Have a great day.
In terms of showing work, this is our last problem. That's going to be 13 over 36. So in terms of showing work, you know, I am going to need to see your process. You are going to have to show steps, but I don't need to see every single step throughout this class. What I mean is this, you know, when you add fractions in middle school, you know, they might have you show, well, I need to multiply this first one by 4 over 4, and then the second one by 9 over 9. I don't need to see that stuff. If you need to do that to help yourself out, by all means do it. I'm not saying it's bad. But if you know, like, in your head, you're just multiplying these by 4 and these two by 9, that's fine. You know, that kind of goes hand in hand where if I have you solve an equation like this, you know, I don't need to see divide by 2, divide by 2. I don't have to see that. You could just divide by 2 in your head and write x equals 5. So little things like that I don't need to see. In fact, a lot of times I think that bogs down some of the math, but we'll get into that as the year goes on. All right, you have some practice to work on. If you have any questions, please email me, and I'll get back to you as soon as I can.